Okay, thank you very much for this very kind invitation. It's a great pleasure to be here. I'm very happy to have the opportunity to present some of the insights of our research to practitioners, which are actually those who should be probably most interested in what we do. So this is kind of research we started quite some time ago. We wanted to systematically look at the valuation of hedge funds of different types. And available, of course, we have different type of data structures, particular returns, in order to systematically address over time which funds are performing, which funds are not performing. And it turns out that if you want to do this in a kind of scientifically correct way, this is a very challenging problem for several reasons. The data that you get are very dirty. There are several funds you would like to assess. You would like to discern skill from luck. You don't know exactly what are the risk factors to which the funds are exposed, and so on and so forth. And addressing all these questions together is really very challenging. But the important thing today is that in order to address this seriously, what you need to have is a consistent approach from the start to the end. By this, I mean that you have to be very consistent in structuring the data, analyzing their properties, performing basic statistics, and then you have to be still, again, very consistent in terms of which methods you apply to look at the performance, which benchmark model you use, and so on and so forth. And in terms of computer type of skills, if you want, this is very challenging because basically you have to digitalize all the process from getting the data to getting the performance. And this is now where we are. So basically, we have an infrastructure to do that systematically. It's even accessible online on the cloud. And that's basically due to the recent developments in this area where it's very easy to have a very strong computer power at very low cost. And so this makes actually this research now feasible. Okay? So what I'm going to do is, first of all, just to discuss in 1 minute what is, in my view, data science. There is a lot of jargon around in this area, big data, data science, and so on and so forth. It's not clear to everybody, I think, what it is, or maybe there are several interpretations. And then I will just show you how we approach the problem of hedge fund valuation, performance, and selection using a systematic data science approach. Okay? So just in terms of old ideas, which are actually not so old, I think they're very new. I have here a citation of John Tukey, which was probably one of the two most influential statisticians in the last century, who was already asking around 62 statisticians to think about data analysis, the analysis of data in a general sense, as a full holistic kind of science. Starting from thinking about what the data are, how they should be processed, which kind of method we should use actually to evaluate them, which kind of features we should look at in order to have prediction skills, and so on and so forth. And this was actually a very influential paper at that time. It was a paper which has basically no formula. It was just putting in the area the issue that most of statistics was actually looking at very complicated models, fancy mathematical theorems, but we are forgetting about the fact that the end statistics is about data analysis and getting structure from the data in order to learn information from the data to do prediction. And this is now where somehow more recently with data science, the whole area is coming back, and I think it's very important because what we want to do at the end is to learn about reality and from this reality to be able to predict the future of reality, so to speak. So in terms of a very short and simple definition, from our perspective, data science is the empirical and methodological synthesis of all kinds of information you can get from the data from when you start looking at them to the end where you produce the results of your analysis. And I'm saying that because when you go to hedge funds, for example, several steps in all this life cycle process will be important for the result of the analysis. So depending on how you address the first question on the data, on how you process them, which method you take, and so on and so forth, actually the final result about which fund could be measured as being performing might change. And it's very important to have a very consistent approach to the whole process here. So what do? We take this holistic view on how we should process information from the data, from the beginning to the start, to the hedge fund area, basically accounting, I would say, for any kind of recent development in science and academics on this type of questions. So what we have in a nutshell is a workflow for processing data from the start about hedge funds to summarizing the kind of benchmark statistics to computing risk factors, to addressing skill, and to selecting funds. Okay, and this is completely optimized. It needs some high-performance computing facility. The main reason is that, first, these data, they become large, especially when you have to keep track of all the vintages over time of the data, and that's very important to measure hedge fund performance. Second, in order to do a selection of funds, which is really accounting for finding skill while controlling for luck, it's very important to simulate several characteristics of returns. And this kind of simulation, they're needed because many things are not available analytically, and for doing the simulation, we need really some kind of high-performance computing facility. So given that we have that, what we're going to have, I'm going to show you the details in terms of data evidence and so on. We are going to process all relevant data, risk factors, individual characteristics, and so on, which are necessary to measure, first of all, risk factors and then performance. And then we are going to have a statistical approach to identify the performing funds. So first of all, in a given cross-section, which are those which, when you account for statistical estimation risk, and when you account for luck, which are the funds which are going to be identified having performed at a given point in time. But then, more importantly, we want to identify performance which is indicative of future performance. Because what you want to have at the end is not only to identify who has been good now, which fund has been good now, you want to identify whether in the future those funds you identify are going to be performing. And that's a very key thing. So it's the issue about the forecasting of performance, which is very, very important, and also actually very difficult because I'm going to show you that depending on how you process the data, you can have very different questions about selections and about the ability of forecasting performance. So this is what I mean here, to detect skill, so risk-adjusted performance, robust to luck. So you don't want to find a fund as being identified as good simply because of your estimation risk in your statistical procedure. There is some probability of finding, of identifying a fund which is not performing as performing. Okay, so very basic background is not that I want to make a summary about hedge funds. You all know much more than what I do about them. But it's more important, in my view, to keep in mind some characteristics which are going to be important for thinking about what are the data features we're going to have, which might actually then impact on some of our conclusions and procedures. Okay? So, of course, these investment companies are largely unregulated. They actually play a big variety of possible strategies, leverage or less leverage, derivative, not derivative. There are many asset classes actually inside this class. So it's very important to have a flexible class of models to account for the potential risk to which these funds are exposed. And so you need to have basically a very flexible and general environment in order to account for the general and flexible structure of these strategies. And the fact that these strategies are, they have a lot of variety, of course, and sophistication will actually be one additional challenge in terms of the kind of computational needs you will have in order to basically identify the risk factors for each class, for each fund, then simulating the possible scenarios, and then selecting the funds which are performing. So in terms of a number of key conceptual aspects, I have here a number of questions. They're very basic questions, but I think it's important to keep them in mind because when we talk about performance in general, it should be always performance adjusted for some potential risk factor, which is somehow kind of natural benchmark. I'm not thinking here in terms of benchmark in the sense that a fund is benchmarked to something, but some trading strategies might actually implicitly play on some risk factors which are relatively easy to replicate or to trade. So if you want to identify skill, you want to identify the part of the return of those funds which is not due to a very simple exposure to other benchmark risk factors, right? So you need to have a kind of very idea on how to model the risk. For example, you can take kind of benchmark returns for different kinds of equity strategies, or you can take different type of derivative instruments and so on and so forth to basically replicate the biggest part of the risk in hedge funds, which is generated in a simple way. But then what you're interested in, of course, is whether there is something additional to it, so the alpha, so to speak, or the skill or the performance, and you want to have a good way and systematic way to identify that. So basically, in any analysis, there will be implicitly a choice of the risk factors in order to measure the alpha, and all the results I'm going to show you that we actually based on essentially the most recent models to benchmark those risks. So every performance I'm going to show is going to be risk adjusted, is going to be in excess of those benchmarks. The other question then is really how to identify performance, okay? And one very brute force and simplistic way would be, okay, I take a cross-sectional funds, I identify the risk, somehow I estimate some excess performance, I have a cross-section of indices of risk-adjusted performance, and I take those which have positive performance, I don't take those which have not positive performance. But this is, of course, something very simplistic, because when you process the data, there will be automatically some variability in these estimates of performance. It would just come from the statistical procedure. So what you want to have is the control for that, okay? So let me just summarize. So basically, the approach we have is every time, every week, or every month, we have a cross-section of funds provided by all professional data providers in the area. So you have on average, originally at least this kind of number of funds. What is important to keep in mind, we are going to keep track of all the vintages of data sets, simply because these are self-reported data. There might be revisions you want actually to take care of because they are informative about future performance and so on and so forth. So this is already quite a challenging task in terms of data structures. You're going to process the data, and there will be duplicates. There will be identifier for each fund you want to have across the different databases. This means actually that if you start to originally, it was about 100,000 entities. At the end, the actual true entities are in the total of 5,000 to 6,000 per period. But this, of course, requires a kind of systematic approach to processing them. And as I said, taking care of the vintages of all the data is very important. I'm going to show you an example in a second. This is just a visual summary on how all these different funds are collected across databases, just to tell you how complex it is in the end to identify a fund that is nominally presented in several databases as a unique representative of the corresponding return series. So let me skip that because of time. It's not so informative. So what I want to do now is to show you some of our results, okay? So I'm going to focus among all these items which are actually big challenges in identifying performance. We'll focus on two items which are very illustrative. So first is the fact you have to take care of the fact that when you look at return data from most hedge fund providers, this is self-reported information, okay? It means actually the funds they report, and there is not really a very strong control with the report. It can actually be the case that over time, some funds communicate to the data provider that in the past, the return they communicated was wrong, and this is going to be adjusted. That's the reason why you have to take care, basically, of all the vintages of the data in order to be sure about what you have in the data. Okay? And the other point which I have here, which is, of course, important, when you select the performing units out of a cross-section of funds, you have always to keep in mind that there is a probability to detecting a unit as a good fund, even though it is not in reality. That's a statistical risk, right? And if you have two hypotheses to test, that's a standard kind of first bachelor class in statistics where you start comparing things. But here we have cross-section of about 5,000 funds. And if you want to control all the possible probability of this area, it's very, very challenging. Therefore, you need to simulate, and that's why we need this high-performance computing stuff, okay? So, so let me just go directly to an example to show you the importance of keeping self-reported information in the vintages over time. So there's a very nice paper in the Journal of Finance by some colleagues in Oxford at the Duke. So what they've done is a very simple exercise, a very simple paper, almost no formula. So what they've done is that they've kept track of all the vintages of the data provided by professional data providers, and they've looked at which funds over time they revised their returns. Okay? At any point in time, they sorted basically the funds by those who said in the past at some point, I have revised some return, and those which didn't. Okay? And of course, if revisions are just random, you would expect the two sets of funds to perform the same way. What these authors find here is that instead, revisions are informative to the point that the non-revising funds have much higher risk-adjusted performance than the revising funds. Okay, so to give you an idea here, I have a graph, this is the total performance, here's the cumulative alpha. In blue, you have just the alpha of the funds sorted with a criterion at time t they never revised before, with respect in red to the alpha of the funds sorted according to criterion sometime in the past you revised. And you see the difference alpha without any kind of additional benchmark is very large. Okay? So actually it means that revisions are informative about the state of difficulty of the fund. So when you do performance analysis, when you process the data, that's a very important kind of aspect you should keep in mind. And therefore this means you need to keep track of all the vintages. Right? The second thing, which is also very important, is partly related to the previous point, is the fact that these data are quite dirty. They're self-reported, there are errors, there are some returns which are gigantic, of course, which might be in some cases be a good information on the fact that the fund was very clever in selecting the investment strategy. In some cases there might be errors. So which means that since the data are dirty, you have to be a bit careful in how you process them. So when you measure performance, you need an approach which is not too sensitive to small distortions in this data. So what I have here, just to give you an idea, in brown, this is the cross-section of alphas of risk-adjusted performance using a method that we call robust, which is not too sensitive to the properties of dirty data. In green, you have, for each fund, the performance calculated with a method which is instead sensitive to the dirtiness of the data. By the way, these are the classical methods which are used basically in 99.9% of the literature, like benchmark factor models and so on. So what you see is actually that if with a classical method you would, for example, measure here risk-adjusted performance 2%, what you're going to have, if you control for the dirtiness of the data, actually is much less. That's just on an individual fund level, but it's more important to look at the fact that when you look at the cross-section, right, this is the cross-section for performances, you have to decide at one point in time which funds are performing and which not. According to the brown line, you're going to have some part of the funds basically from here to here, which are going to be identified as significantly performing. According to the green line, it can be very volatile what you get. Okay? And this is really a danger, especially because this kind of effects can actually generate performance which is not visible out of sample. That's the big point, right? I'm done. So here, I just want to show you, with our robust method, essentially what is going to happen compared to basic standard approaches, recent but standard approaches in the literature. So essentially you see here over time, for different periods, the number of funds selected as being performing statistically, right? So this is how the classical approach will work. Basically, we identify on average 50 funds per period, and especially when you get into the period of financial crisis, you're very much troubles in finding some performing funds. In contrast, the robust method, you see that basically it always identifies something like, let's say, 15% of performing funds. Moreover, what is more important is that the type of performance, so the identification of performance here will be persistent in the sense that often a large fraction of funds identified today as being producing alpha, they will be producing alpha in the future. This is the first requirement in order to get a good forecast of performance. And to conclude, this is how, in the end, the total risk-adjusted performance will look like. So, for example, here what we have is in red, an equally weighted portfolio of the funds selected by our method every period. You have in brown or hair green here the line of the equally weighted portfolio of funds selected with benchmark approaches, and the other lines are just equally weighted indices of different standard indices of hedge funds. So what you see is that the out-of-sample performance of the robust method here and here is substantially larger, and also has the feature that during the financial crisis, it allows you to get a faster recovery. The main reason is that the robust method was still selecting before the crisis some funds betting on a change in the trend of the market, while the other methods, because of this dependence, very dirty data, they didn't do it. Okay? So as a summary, it's really possible to systematically apply a general, broad, consistent data science approach, accounting for all the different statistical difficulties of selecting funds. And our finding, what I tend to tell you, is that actually compared to the existing literature, there is even more performance in that industry than what is typically found with other methods that don't account for the properties of hedge fund data. All right. Thank you.